So if you're just joining, we're going to start in a few minutes. So today we're going to be going over challenge problems, which means this class is probably going to be harder than last time. And if you guys want, the first problem is up here for you guys to try out. Okay, guys, so it's 6 o'clock, so let's get started here. You guys have a few minutes to do this problem. And some of you have already gotten the answer, which is cool. Someone asked if the exterior angle theorem is part of the solution. The answer is yes. Okay, so let's go ahead and get started. So the problems today are going to be approximately ordered from easiest to hardest. And our first question here is, three isosceles triangles are put together to create a larger isosceles triangle as shown. What is the value of x? So if some of you guys are new to geometric diagrams, then basically what this line means is that any side with that same mark on it has equal length. And similarly, with the double slash here and the double slash here, that means those two sides have equal length. And so a property of triangles is if you have an isosceles triangle where this side and this side are equal, then that means that this angle is equal to this angle. So the opposite angles are equal. So in this case, in the diagram, this line is facing 35 degrees. And since this line has the same marking, this is also 35 degrees. And so if you look at this triangle, by the exterior angle theorem, that means that this is 70 degrees. And since this length and this length are equal, that means their opposite angles are equal. So this is also 35. And similarly, this is 35, which means this is 70. If you guys notice, then we actually have an axis of symmetry through this line in the triangle, which is why it kind of looks like a mirror image. And since the angles of a triangle add up to 180 degrees, in this triangle, angle X is equal to 180 minus 70 minus 70, which is equal to 40 degrees. So props to anyone who got that. Someone asked if why the angle was 70 degrees. That's because if you remember last time, hang on, you'll remember last time, if we have a triangle and we extend the bottom side out in a straight line, this angle is always equal to the sum of the two opposite angles, or this angle and this angle added together. And that's called the exterior angle theorem. So let's move on to the next question. In triangle PQR, the lengths of sides PQ and PR are the same. The point S lies on QR so that QS is equal to PS, and RPS is equal to 75 degrees. What is the size of angle QRP? And we have our diagram over here in the top right corner. Uh, Guys, keep in mind that there are 5 answer choices here. And so the answer is one of these 5. QRP is this angle. Okay, it looks like several people got some answers. So let's go ahead and start with this problem. So if you look here on our triangle, these two sides are marked, which means that whatever angle QRP is, it's the same thing as angle PQR, or this angle. And this triangle is isosceles. What you'll also notice is that in triangle QPS, we have these two markings here, which means it's also an isosceles triangle. So this angle is equal to the other two. And we're given that angle SPR is 75 degrees. So what this means is now we can use the information that the angles of a triangle add up to 180 degrees. So if we let angle QRP equal to X, then we can write an equation here because there's 1, 2, 3 identical angles called X, which means that 3X plus 75 degrees is equal to 180. And if you simplify, you get 3x is equal to 105, or x is equal to 35. Which means the answer is A. Someone asked, how did I get 180 degrees? So we learned last class that the three angles of any triangle always add up to 180 degrees. And remember that 180 degrees is the angle measure of a line. Okay, so let's move on to the next problem. The diagram shows a square, an equilateral triangle, and a regular pentagon. What is the size of angle WUV? So this is slightly harder than the last few. WUV, in order to get that, you need to connect a line. Which means that this angle here is WUV. And so some of you are probably wondering, that's kind of a weird angle, right? Because this imaginary blue line we draw wasn't there originally. But you don't have to solve for WUV directly. And you can use the fact that since these are all regular shapes, we know that this length is equal to this length, which means that triangle WUV is actually isosceles. And don't forget, in the previous class, we also learned that the sum of the angles in a polygon with insides is 180 times n minus 2. Also keep in mind, if you're not sure what exactly this formula is, you can try to plug in some simple cases. So for example, we know that for a triangle, the sum of the angles is 180 degrees. And this formula makes sense because a triangle is 3 sides, which means that n equals 3. And plugging it back into this formula gives 180. Okay, so let's go ahead and get started here. Okay, so if you use the formula, then you should be able to get that each angle in the pentagon is 108 degrees. And each angle in the square is 90 degrees. And each angle in the equilateral triangle is 60 degrees. So since we know that these two sides are equal, that means that the angles they're facing here are also equal. And whoopsie, something just appeared on the screen. There we go. So this means that all we need to do is find angle WVU, which is right here. And we can do 180 minus angle WVU and divide that by 2 to get our answer. So now all we need to find is WVU. Oh, whoopsie, sorry. So angle WVU is actually just made up of angle WVR plus angle UVR, because you can split it in half by line VR. So what is WVR? Well, that is just the angle of the square, which is equal to angle PVR, minus the angle of the triangle, which is equal to angle PVW. And what's angle UVR? Well, UVR is just one angle in the regular pentagon, which we got here is 108 degrees. So if you do some further simplification, angle PVR is just the corner of the square, so 90 degrees. PVW is an angle of the equilateral triangle, so 60 degrees. And then adding back 108. And calculating this gives you 138 degrees. So now we plug this back into our answer here. And we get that 180 minus 138 divided by 2 is equal to 180 minus 138 equal to 42. So that divided by 2 is equal to 21. Which means the answer is A. So this question was a little harder than the last ones because you had to kind of think outside of the box and draw the line yourself. But you see these kinds of problems a lot in geometry, and you have to look out for what kind of lines to draw. So let's clear this and move on to the next question. The diagram shows a square inside an equilateral triangle. What is the value of x plus y? For this problem, you also have to kind of think outside the box. Notice that you don't actually have to get what x and y actually are in order to solve the problem. Some of you might be stuck on this, so let's just do a little bit of it. So basically what we're looking for is x plus y. Notice that this whole thing is an equilateral triangle, which means each of its angles are 60. So this is 60, and this is 60. And notice that x belongs to this triangle and y belongs to this triangle. And if we label this angle A and this angle B, then what can you write x and y in terms of? Okay, so we notice that since each of these blue triangles, their angles add up to 180 degrees, so we know that x plus 60 plus a is equal to 180 degrees, and y plus 60 plus b is also equal to 180 degrees. So if we move each of these 60s to the other side, get that x plus a is equal to 120, and y plus b is equal to 120. And if you add these two equations together, you get x plus y plus a plus b is equal to 240. Since they're asking us for x plus y, which is this thing, somehow we need to get rid of a plus b. And if you're thinking about how to do that, the best way to go about it is look back at the problem. And what piece of information have we not used yet? That's the information that this gray thing right here is a square. And since it's a square, each of its corners is 90 degrees. And since this bottom base here is a line, that means that a plus b plus 90 is equal to the line, which is 180, which means that a plus b is equal to 90 when you subtract 90 from both sides. And so here we have what a plus b is. And if we plug that back here, you get that x plus y plus 90 is equal to 240, which means that x plus y is equal to 150. Okay, so sorry, quickly guys, we have to log out and log back in because for some reason 40 minutes already passed and that's the free limit. So when this session times out, just make sure to log back in the room again and we can restart this class, okay? Okay, it looks like we should be all good here. Can anyone hear me okay? Okay, good. So let's move on to the next problem here, which I think is this one. Yeah. Okay, so in the diagram, AB is equal to AC, and D is a point on AC such that BD is equal to BC. Angle BAC is 40 degrees. What is angle ABD? So let's just start here. They say that AB is equal to AC. And typically when you're doing geometry problems, if they give you something and it's not marked in the diagram, then you should probably mark it. So AB is this length is equal to AC, which is this length. And that means that this is an isosceles triangle. So this angle and this angle are equal. Now, since they give you that this is 40 degrees, and you know that these three angles sum up to 180 degrees, then that means each of these angles is 180 minus 40 divided by 2, which is 70 degrees. So you know that this angle here is 70 degrees. That looks like a 76. 70 degrees. This angle here is 70 degrees. They also tell you that BD is equal to BC. So BD is here, is equal to BC, which is here. So that means that triangle CDB is isosceles, which means that angle C and angle D here are also equal. So if this is 70, then this should be 72. And they're asking us for angle ABD. And ABD is this angle here. So if you guys notice, we have the exterior angle theorem right here. So if we take triangle ADB and extend the base, then we know that this 70-degree angle here, let me write this down. So the 70-degree angle here is equal to the 40-degree angle plus the red angle, which is what we're trying to find. And solving this gives you angle ABD is equal to 30 degrees. And that should be our answer. So does anyone have any questions? Keep in mind, guys, someone just made a comment about this. This 70-degree angle here is referring to angle ABC, not angle DBC. Actually, since this is 30 here, angle DBC would actually be 40, not 70. So there is no 70, 70, 70 triangle. And that brings up another thing. When you're marking diagrams like this, make sure you don't get confused about what you're marking. Okay, so let's move onward. The diagram shows a regular hexagon PQRSTU, a square PUWX, and an equilateral triangle UVW. What is the angle TVU? So angle TVU is this angle right here. So this is another one of those problems where you actually have to draw an extra line. So let's get started. So since every single shape in here is regular, that means that this side is equal to this side, which is equal to this side, which is equal to this side. And notably, that means that VU is equal to VUT, which is yet again another isosceles triangle, which means that the angle they're looking for is also equal to the angle UTV. So just as we did for previous problems, all we have to do is find angle VUT and then subtract that from 180, divide by 2, and that will give us our answer. So now we ask ourselves, how do we find VUT? Well, VUT is this angle. And if you'll notice, we actually have a bunch of angles right here in the ring around the middle. So any angles that actually are in a circular formation add up to 360 degrees, because that's how many degrees are in the circle. So that means the red angle plus the yellow angle plus the blue angle plus the green angle sum up to 360 degrees. Now, the red angle is what we're trying to find, which is VUT. The yellow angle is actually just an angle in triangle WVU, which is equilateral, so we know it's 60. The blue angle is a corner of square WUPX, so we know that's 90. And the green angle is an angle of the regular hexagon, so that is 120. And for those of you wondering, each angle in a regular hexagon is 120, and that's probably a fact you should memorize. But don't forget that you get it from that formula we discussed before. So if you solve this equation, you get VUT is 360 minus 120 minus 90 minus 60 which is equal to, if you group these two together, that's just 240. And if you group these two together, that's minus 150. So that gives you to a total of 90 degrees. Now don't forget that this is not our answer, because we still need to plug it back into this formula. And when you're doing questions like, for example, on the AMC 8, a lot of times the problem writers will actually put this as an answer choice. So you would have like A, B, C, D, E, and then you would have choice F here, which is 90 degrees. But don't be tricked by that, because that is not what they're looking for. They're actually looking for 180 minus VUT, which is 90, divided by 2. And that is equal to 45 degrees, which is A. By the way, someone mentioned this. The reason we can do negative 90 and negative 60 here combined to negative 150 is that we can take the negative sign out. So this term here is actually the same thing as negative 90 plus negative 60. And you can take a negative 1 out, which gives 90 plus 60, which gives negative 150. So that's how we got the negative 150 here. Okay, so moving on to the next question here. We still have some time left, so find W in the diagram. See, so you'll notice that this diagram is just a bunch of lines at a bunch of angles. And a hint is that the way you solve this is you draw a bunch of other lines which are parallel to the ones you see in the diagram. So let me just draw some lines to hint. So to solve this problem, we need to draw this line, which I know is not very straight, but it's supposed to be parallel to A, B, and EF. And we now need to draw that line, which is also parallel. And don't forget, if some of you guys were around for our warm-up last week, what we know from two parallel lines crossed by a transversal. Okay, so some people here are starting to get answers, so let's get started. So if you remember from last week, we have two parallel lines and we have a transversal. And that means that this angle and this angle are equal. So if you look here, that is exactly the situation we have with all these parallel lines. We have line here, line here. Oh wait, that was horrible. Line here. And they give us that this is 45 degrees. So from what we know here, that means that this also has to be 45 degrees. But if BCD is the whole thing is 85, then that means just the other angle is 85 minus 45, which is equal to 40 degrees. So this angle here is 40 degrees. But if we use the same thing again, this time with this transversal, then we know that this angle is also 40 degrees by the same thing here. And so basically we already found part of W. And the other part of W comes from the right side of the diagram, where we notice that this is also transversal, which means that if this is 50 degrees, then this angle here is 50 degrees. So then W is equal to 40 plus 50 is equal to 90 degrees. So we unfortunately do not have enough time to go over the rest of the problems here. But what I can do is we can assign the rest of the problems as homework so that we can start a new topic next week. So we have this problem here, which is actually a very cool problem because it involves you having to draw additional sides. We have this angle, thing here, which involves a lot of angle chasing. And finally, we have this clock problem, which is not your typical geometry problem, but it involves a lot of the same concepts. So we're done over here. I just want to remind you guys that our website has actually been moved to alphademic.weebly.com, and we're hoping to switch over to a real website domain soon. And if you guys want, there are additional classes on the website. Like, for example, this week, we just added 3 more classes, writing, debate, and biology. So if you guys want to check out those classes, you can visit our website and complete a join form. And also don't forget to go to Benjamin's Q&A session that's directly after this, up until 7 o'clock. So that's it for this week, guys, and I will see you next time.